A mountain that more than 100,000 people photograph, hike, and drive past every single day just did something it has never done before in the entire history of modern monitoring. Not an eruption, not lava, just the ground itself, shaking harder and longer than anyone alive has ever recorded there. And almost nobody outside a small circle of scientists noticed it was happening at all. Here's what most people assume about dangerous volcanoes. They picture fire, glowing rivers of rock pouring down a slope while helicopters circle overhead. So it's easy to assume the most dangerous volcano in America must be the one erupting the most, but that assumption is wrong, and it's wrong in a way that matters. The volcano, the U.S. Geological Survey, actually ranks as the single most dangerous in the entire country, barely erupts at all. It hasn't had a real eruption in roughly 1,000 years. Danger, it turns out, isn't about how often a volcano erupts. It's about how many people are sitting directly in the path of what happens if it ever does. That distinction is exactly why this video exists. When the earthquake swarm hit in the summer of 2025, a lot of coverage leaned straight into the scariest possible headline without explaining what the data showed. So instead of repeating that, we went to the source. We pulled monitoring reports from the USGS Cascades Volcano Observatory, emergency planning records from Pierce County, Washington, and the University Seismic Network that first caught this in real time. Because the real story here isn't just scarier than the headlines, it's stranger and more useful to actually understand. Here's how that danger ranking actually works, because it's the key to almost everything in this video. The USGS keeps something called the National Volcanic Threat Assessment, and it doesn't just count eruptions. It weighs eruption potential against exposure, meaning how much infrastructure and how many people sit close enough to actually get hurt. A volcano that erupts constantly out in the middle of nowhere can rank surprisingly low. A volcano that barely erupts at all, but sits directly upstream from hundreds of thousands of homes, can rank at the very top of the entire list. That single distinction is why this mountain has held the #1 spot for years, even through long stretches when it does nothing newsworthy at all. So let's start with the number that changed this past year. In the first 12 hours of the swarm alone, scientists recorded more than 40 earthquakes an hour at the busiest point. By the end of the first week, they'd already located over 1,000 separate quakes. By the time it slowed down almost 7 weeks later, the total had climbed past 1,300 events. Researchers believe the real count was higher once you factor in the smaller quakes their instruments couldn't fully pin down. That's more seismic activity in one summer than this volcano produced in the 15 years before it combined. This wasn't a blip. This was the loudest this mountain has been since anyone started listening with modern equipment. And it happened while hikers were still climbing toward the summit and campers were still pitching tents in its shadow with no visible sign. Anything unusual was going on. Now, if your mind immediately jumped to the word eruption, that's a reasonable place to land. But it's worth slowing down because the full picture scientists found is more careful and more interesting than a scary number alone suggests. A swarm behaves differently from a main shock aftershock sequence, where one big quake hits first and everything after gradually fades. A swarm can ramp up, hold steady, or keep growing for weeks with no single dominant quake, which is exactly what happened here. Under normal conditions, this volcano produces something like 10 small earthquakes a month, quiet background noise from an active hot water system running beneath the surface. Every so often, it has a short swarm, maybe once or twice a year, and that's considered ordinary. But here's the strange part. The single strongest quake in this entire 7-week swarm only reached a magnitude of 2.3, too small to feel standing right on the summit. The old record, set back in 2009, was about 1,000 quakes crammed into 3 days. This new swarm didn't just edge past that record, it buried it in total count, in how fast the quakes came and in how long it kept going. So more shaking than this mountain has ever produced, but barely strong enough to register as anything on the surface. That gap between record-breaking and physically unnoticeable sent scientists straight into investigation mode. They didn't lean on just one signal. They checked at GPS stations planted around the volcano's slopes that can detect even a slight bulge in the ground, the kind of change you'd expect if molten rock were pushing toward the surface. Nothing moved, not by a measurable amount. They checked infrasound sensors next, instruments sensitive enough to pick up sound waves too low for human ears, the kind of rockfall or small explosion would leave behind. Nothing unusual turned up there either. They reviewed webcam footage pointed at the summit's steam vents, watching frame by frame for any change in how much steam was escaping. Still nothing. Then came the step that shows how seriously they were taking this. In early August, a USGS team partnered with the National Park Service and flew a helicopter directly over the summit craters, sampling gases from those vents by hand. Here's why that mattered. If magma were rising toward the surface, you'd expect a clear jump in sulfur dioxide relative to the other gases present. The results came back almost identical to readings taken long before the swarm started. No meaningful shift at all. Every tool they used, ground shape, sound, sight, and chemistry, pointed to the same conclusion, and the volcano's alert level never moved off normal for a single day of the entire 7 weeks. So if it wasn't magma, what actually caused 1,300 earthquakes underneath one of the most closely watched mountains on the planet? The leading explanation is hydrothermal fluid movement, and understanding it is the key to this whole story. Deep inside the volcano, heat rising from magma far below has been slowly cooking underground water for thousands of years. That superheated water and steam pushes upward through cracks and fault lines, and every time it moves, it chemically changes the minerals it passes through. Solid volcanic stone slowly turns into something closer to soft, crumbling clay. Picture a spoon left sitting in a hot cup of tea, and in the first few minutes, almost nothing seems to happen. But stretch that same slow process out across thousands of years instead of a few minutes, and the material doesn't just look different anymore, it actually changes at a structural level. That, roughly, is what's been quietly happening inside this mountain long before any scientist pointed an instrument at it. As pulses of hot fluid pushed through existing cracks in the summer of 2025, they acted almost like a lubricant, letting sections of already weakened rock slip and grind against each other, releasing bursts of energy that showed up as small earthquakes. This process has happened before here, just at a much smaller scale. It had simply never happened on anything close to this size or for this long in the entire span of modern record keeping. And here's the part that matters most for the rest of this story. This process doesn't need an eruption to keep running, and it doesn't need one to eventually cause a serious problem either. Quick gut check for you. If you had to guess how you'd honestly react to news like this if you lived nearby, comment calm or worried below, and let's see which one wins by the end of the day. And if this kind of deep dive into what's actually happening beneath the surface is useful to you, hit like right now, because it's the fastest way to tell YouTube to put this in front of more people living near mountains, exactly like this one. Here's the part. Most coverage of the swarm barely touched, and it's arguably the more important half of this entire story. All that weakened clay-like rock beneath the summit isn't just sitting there in isolation. It's directly holding up roughly 93 square kilometers of permanent glacier ice, spread across around 26 named glaciers, making this the largest glacier system found on any single mountain in the lower 48 states. Try picturing that scale. That's enough frozen water to bury tens of thousands of football fields under ice thick enough to swallow a house whole. Now picture a snow fort built directly on top of a sandcastle, except the sandcastle underneath is slowly being soaked from below by a hose you can't see and can't turn off. From above, the fort still looks solid. Underneath, the foundation is quietly losing strength, a little more with every passing year. And that ice isn't sitting still either. Regional warming has sharply sped up glacier melt here in recent years, with several named glaciers disappearing off the map entirely, retreating past the point scientists even count them as active. It's right in line with a pattern playing out at mountain glaciers worldwide, from the Alps to the Andes. Here's a comparison that should make this sink in properly. This mountain currently holds roughly 8 times as much glacial ice as a volcano called Nevado del Ruiz held back in 1985. Nevado del Ruiz sits in Colombia, similarly capped in snow and ice, and that year a relatively modest eruption, nowhere near the most powerful on record, melted the ice on its summit almost instantly. That meltwater mixed with ash and loose rock into a churning wall of mud that swept downhill and swallowed a town called Armero within minutes. More than 23,000 people lost their lives that day, from an eruption geologists describe as genuinely modest. The mud, not the lava, is what did the damage. Now hold that number in your head, and remember this mountain is currently sitting on roughly 8 times more glacial ice than Ruiz had available to melt. Which brings us to the actual danger scientists lose sleep over, and it isn't lava at all. It's something called a lahar, a fast-moving flow of mud, water, rock, and shredded trees. It can move down a mountainside faster than most vehicles travel on a highway, and keep moving fast for dozens of miles after the slope levels out. People who've witnessed one describe it as wet concrete moving at the highway speed, thick enough to flatten buildings and snap bridges. Here's the single fact that should change how you think about this entire mountain. A lahar does not require an eruption to happen. Not lava, not an explosion, nothing volcanic in the traditional sense. All it needs is heat, water, and rock that's already been chemically weakened, and this mountain has all 3 stacked directly on top of each other right now, whether it ever erupts again in our lifetimes or not. That's not a hypothetical scenario. It's happened here before, more than once. Around 500 years ago, in an event geologists now call the Electron Mudflow, a section of that weakened rock simply gave way on its own, with no eruption involved, and roared downhill toward what's now the Puget Sound region. Go back further, roughly 5,600 years, to the largest one on record here, called the Osceola Mudflow. That flow carried enough volcanic debris to fill more than 1 million Olympic-sized swimming pools, traveling more than 60 miles from the summit. It buried valleys that are now covered in homes, farms, and busy highways people drive without a second thought every single day. Today, more than 150,000 people live directly on top of the debris those past mudflows left behind, in towns like Orting, Puyallup, Sumner, and Buckley. Sitting inside the same river valleys, a future lahar would most likely follow. These aren't empty danger zones marked on some hazard map nobody looks at. They're ordinary towns with grocery stores, little league fields, coffee shops, and school buses running the same routes every morning. Puyallup hosts a well-known county fair every year. Commuters in Sumner and Buckley take the same highways into Tacoma and Seattle for work, day after day, without giving what's upstream a second thought. None of it feels dangerous standing there. It just feels like home, which is exactly what makes a slow-building hazard like this one so easy to forget in the middle of an ordinary week. Because a lahar triggered by a sudden landslide could theoretically arrive with almost no warning, this region has built one of the most advanced volcano warning systems found anywhere in the world, engineered specifically around this one threat. Buried sensors along the mountain's most historically active valleys listen constantly for the exact ground vibration a lahar makes as it starts moving, feeding data instantly to emergency operations centers, staffed around the clock, connected to outdoor sirens built to get people moving before a phone alert even has time to catch up. And this isn't just sitting on paper gathering dust. In April of 2026, communities across East Pierce County ran a full-scale regional lahar evacuation drill, moving tens of thousands of students and staff through real marked evacuation routes. It was coordinated across multiple school districts and emergency agencies at once, described as one of the largest exercises of its kind held anywhere in the world. That drill happened just months after the historic swarm, in the exact same towns that live quietly in this mountain's shadow. If you want to know whether you or anyone you know actually sits inside one of these mapped hazard zones, that's worth 5 minutes of looking up today, not filed away for someday. So let's pull this back together, because on their own these facts are alarming, but stacked together they form one connected system rather than 5 separate scares. In the summer of 2025, this mountain produced the largest earthquake swarm ever recorded there. More than 1,300 quakes across 7 weeks. Scientists ruled out magma using every tool available, from ground GPS to hand-sampled volcanic gas, and traced the real cause back to hydrothermal fluid, slowly turning solid rock into weak, crumbling clay. That's a process that's been quietly running underground for thousands of years already. That weakened rock sits directly beneath one of the largest glacier systems anywhere in the lower 48 states. Ice that's now melting faster than it used to because of a warming climate, adding even more water to a mountain that already holds more meltwater potential than the volcano that buried Armero back in 1985. And every bit of that sits directly above real towns. Towns protected today by a real, tested warning system that just ran one of the largest evacuation drills on the entire planet. One system. Rock, water, ice, and people, all connected, all still quietly moving, whether this volcano ever produces another drop of lava or not. If there's one thing worth sitting with after everything we've just covered, it's this. The volcano drawing the most tourists, the one whose snowy shape shows up on postcards and license plates across an entire state, is also the one carrying the country's single most serious lahar risk. Not because it's the most explosive volcano out there, because of exactly how much ice sits on exactly how much weakened rock, directly above exactly how many people going about their ordinary lives underneath it. Right now, the alert level sits at normal. There's no sign of an eruption building anywhere in the data, but normal was never the same thing as nothing to watch. And for this particular mountain, it never has been. That's really the whole point of a story like this one. The danger was never hiding. It was written into rock samples, glacier surveys, and monitoring reports that most of us never think to read, sitting quietly in the background of a place people visit for the view, not for the risk. If someone in your life lives anywhere near Puget Sound, or just needs to understand why scientists keep such a close eye on a mountain that looks perfectly calm from a distance, send them this video today. That's worth more to them than a comment ever could be. Next time, we're going deeper into exactly how that warning system actually works underground, sensor by sensor, and what a real evacuation genuinely looks like from the inside, from the first vibration to the last family reaching higher ground. Stay curious and keep watching closely for what the ground beneath your feet is actually trying to tell you.